acids can be classified into strong acids and weak acids. In this video, we are going to learn the difference between both strong and weak acids. Hydrogen chloride HCl is a gas. It shows its acidic properties when it dissolves in water. You can see that when HCl dissolves in water, it gives H3O plus ions, indicating that it's acid. And notice that we use an equilibrium sign in the equation when hydrogen chloride is added to water. This is because the reaction is reversible. However, because hydrochloric acid is a strong acid, the position of the equilibrium lies well over to the right-hand side of the equation. In other words, almost all molecules of HCl dissociate in water to form ions. So let's demonstrate what happens when hydrogen chloride gas is dissolved in water. Hydrogen chloride gas enters through the funnel immersed in a beaker filled with water. The hydrogen chloride gas splits up into ions, and the solution is now called hydrochloric acid. All the hydrogen chloride molecules dissociate into ions when in water, and this is what makes the hydrochloric acid a strong acid, because it completely dissociates in water. Weak acids, on the other hand, will have the usual reactions of acids, but given solutions of equal concentration, their reactions will be slower than those of a strong acid. For example, ethanoic acid, CH3COOH, is an example of a weak acid. When we add it to water, we get this reaction. In the reaction, the position of equilibrium lies towards the left side hand of the equation. Unlike in a strong acid, there is a high proportion of the undissociated ethanoic acid molecules in the solution. So if we start with a strong and a weak acid of the same concentration, there will be fewer H plus aqueous ions formed in the weak acid solution than in the strong acid solution. The weak acid does not completely dissociate in water. This is a demonstration of weak acid in water. It will dissociate into ions, but partially, so there will remain weak acid in the solution, and it will not completely dissociate into ions like strong acids. We have those two acids, they have the same concentration, hydrochloric acid and ethanoic acid, and we first test their pH with the universal indicator. And now we add equal amounts of magnesium ribbon to the acids and observe the difference in their reaction rates. More bubbles are produced when magnesium is added to hydrochloric acid, which is the strong acid, so the rate of the reaction is faster. In the next test, we will add equal amounts of calcium carbonate powder to the acids and also observe their reaction rates. These experiments show you that hydrochloric acid is a strong acid and ethanoic acid is a weak acid.